G'day guys, welcome to the October 2020 .NET user group coming to you from Sydney, Australia. We have a big night ahead of us tonight. We have a very special guest. It's going to be a great night. His name is Brendan Richards, and he is going to be talking about a great... One sec. And so Brendan is going to be talking about .NET 5, and we have been looking forward to that for quite some time. So with that, I am going to kick off tonight with a little bit of news first. That would be quite handy. And the news tonight starts with GitHub. GitHub have added some interactivity into their site. So if you're used to using Visual Studio and VS Code where you just navigate through the code, it's nice and easy. They talked about this was one of their blogs they released, code navigation for C# repositories. And what happened, this is the more detail about it, but basically it's a little bit like F12 if you're familiar with that in Visual Studio. You can see a method, see the definitions, and then you can also see the references, so you can see where that's being used. So that's a small thing, but a great thing in GitHub. Another little bit of news is this Blazor architecture guidance that was released. And essentially, the guys in the office started talking about this 4 micro front-end architecture types you can implement with Blazor. It seems that clients love Blazor. We have a few projects running on Blazor at the moment, and this is some approaches you can take if you have, say, a React app and you want to have little kind of widgets done in Blazor. Some people might ask why you might want to do that. There are a few reasons. If you're doing, say, CRUD screens and you want that done in Blazor, but it's inside the React app, that might make sense because Blazor is a lot quicker and faster for heavy data entry, more like the Windows style. You might have a long game where your approach will be to go ahead and end up in Blazor, but you're going to take it piece by piece. So you can piece by piece, widget by widget, develop it in React and do it like that. So that is an approach, and there's some other approaches here too. So that might be interesting for you. Next piece of news I will mention, which I think this is fascinating. The guys often talk about gRPC as being faster than typical JSON, but faster is a little bit subjective. James Newton King, if you remember him from JSON fame, the most popular little assembly we use in Visual Studio, he's got a demo here where it's 70% smaller and deserialization is 10 times faster. So that's let's put some numbers to the excitement. You might remember that Liam Elliott did a nice talk a few months ago on this technology. It's up on SSW TV, so you can watch that on YouTube if you like. Next piece of news I might tell you is we added a new rule here called, do you know the best way to create Azure resources? Now, obviously, most people get going and they go into Azure, they go to the Blade, and then they create the resources they need. That is not the best practices way of repeatability. It's not infrastructure as code. That is the typical way you start seeing people go. So a better way is create them and save the script. An even better way is to use another tool that does that better. So there are a number of tools out there. The video above primarily talks about Farmer, which is in F#, or Pulumi. Now, one of the little highlights I will tell you is this bit. Includes a tool for converting your existing JSON ARM templates into code. And if I just click this little link here, you'll see what I'm talking about. But the guys that have been using this have really enjoyed it. They recommend it heavily. But this turns it into your language of choice. So there you go. It's quite a compelling story here. Okay, and it's not cloud specific. It's cloud agnostic. All right. Next piece of news. Now, I'm not allowed to talk about all the great .NET 5 stuff because I do not want to take any of Brendan's thunder, because Brendan has an entire talk. But I will mention one piece that does get a bit of noise around the office, and that is one of the updates coming in .NET 5 is the Blazor WebAssembly debugging improvements. Okay, so that's an important thing. You can look down and see all the stuff here, but that is a really important piece. Now, moving outside the Microsoft world for a moment, there was a release of the Oculus Quest 2. A few of the SSW guys have already bought this, and they are waiting for it to ship momentarily. And it is pretty cool. Now, on the Microsoft development side of things, you can develop this with Unity and .NET Core, so that's pretty exciting. Of course, somewhat more exciting might be the HoloLens 2, but it is pretty much double the price of this. So if you want to go for the mixed reality version instead of this immersive experience, then that's the way to go. Now, I want to also mention this. Now, JK did a presentation at NDC, and he's often talking about ML development, always in Visual Studio. So now we have the choice of doing our ML development in VS Code. So that's exciting. It's new. It could be a bit rattly, but it's worth knowing that this is a new choice if you want a faster environment. What other news do we have? Well, we can't have news without a little bit of Apple stuff, and there is the iPhone 12. Okay, and here they are. So it is exciting. It's 5G. It's thinner, smaller, and lighter. There we go. So what they probably don't mention on here is when you buy it, you don't get a charger anymore, and no earbuds. So yes, but you get everything else. Okay. Actually, I've been going down this choice because I've been thinking. I just started with. I'm getting a phone for my wife, and I didn't want to get her an Apple. We have too many Apples in the house, so we are going to go Android. Now, obviously, going Android, which one would you go? Now, one of the things worth mentioning is it's not that easy to get the global stats on which is the biggest phones. But I can tell you in general, I've essentially got a bit of a summary for you. I can tell you that Huawei are the biggest, okay? The Chinese firm, they got about, it appears, 16%. You got Samsung with about 15%, Apple with about 12%. You've got Xiaomi, mi.com, there with about 12 too, and then you've got Oppo and Vivo. Now, they've got 10 each. And then the rest, there's a number of others, you know, Motorola, etc., Sony, and they've got 25% left of the pie. So those 6 companies take up the first 75%. Now, I think my guess is that Huawei are going to lose a lot of market share. They've lost their trust in terms of Americans have stopped them using the Google store. There's a lot of just hesitation, so I can't see that market share growing. I expect the war with America to probably continue, or at least to have a lot of effects that go on. And then you've got Apple, which could suffer collateral damage if they're banned in China, which is possible, or that they have to move out of China and start making it in Vietnam or somewhere else. And if that happens, then the price will go up, and then the market share of Apple will go down a little. So, and then you've got all the other ones, you know, Xiaomi and Oppo and Vivo, and they, Chinese, they're going to suffer the same collateral damage. So, what's the long and short of that? I think you're going to find out, you know, in some months or in the next year, that Samsung are now the biggest mobile phone provider, and not by, I think it won't be by just a few percentage points. I think it'll be by a number. It could end up being double the size of the next one underneath. So with that, that means that the S20 phone is probably the way to go if you're going to go that way. If you're trying to get a phone that is mainstream, and then they're little ones that the little, well, not little ones, the expensive ones are also going to get a bit more traction, such as the Fold 2. And so anyway, we'll see what comes of that. Now, just to finish off with a little bit of news. The NDC conference is finished. It was a great week. It was very exciting. Was lots of great talks. Many of the guys here were speaking at it and enjoyed. Obviously, it wasn't as good hanging out because we had to do it all virtually. We ran a track here at SSW. The SSW TV team also did a bunch of interviews. I did a few myself. So they're going to go up on the SSW TV channel, so you can watch those. Plus, all the talks are going up on the NDC YouTube channel. So that should be exciting. So watch out for those ones. What's coming up in terms of events is this one, .NET Conf. And .NET Conf is lots of great sessions here. And what do we got here? You got Scott Hunter, the owner of .NET, so he'll be talking. Claire, Mads, Steve Sanderson, Mr. Blazer. Lots of great talks here. And you can see all the great speakers. We just talked about James Newton King. Oh, there's Scott Hanselman. Awesome. And yeah, so lots and lots of good stuff. Now, what is interesting, I think, is if we were to search on this page and go Blazor, you will see 16 references, and you'll see it all over the joint. So there's lots of references to Blazor, lots of sessions. Okay, so you'll see heaps of that. So it should be exciting. Now, what will we be talking about next month? We will be talking about who won the election. And it sounds like Biden is in front, but you don't know based on last time. I just had this sent to me just 10 minutes ago, and it was kind of funny, so I will show it to you. Apparently Donald Trump, this is an ad that just went up. Biden will listen to the scientists if elected. He wants to listen to Dr. Fauci, and Joe Biden just said, I'm Joe Biden and I approve this message. So there we go. Anyway, if you're American, get out and vote. So I am going to hand things over to Brendan Richards, and before I hand it over to him, I'm just going to tell you that Brendan is he comes from the Java world, came over to SSW, ended up very quickly adopting .NET like faster than any of the guys that had come from the VB6 world on, and he's been doing some amazing projects for many years. He came to me and said, while we were happily doing .NET, I want to do the next project in .NET Core. And I said, it's not out of beta. We don't even have a Go Live license. We talked to Microsoft, they gave us approval, and so we got going with a very large project from the early days. And from that point, we haven't stopped using .NET Core, and he's been running that. So I think it's going to be fascinating to listen to Brendan. He's talking about the migration story from .NET Core to .NET 5. He's going to talk about the migration story from Classic to .NET 5, what he's excited about in there, what is coming in .NET 6. I'm keen to hear, and I am fascinated to hear if he's happy with the naming convention, because there was lots of chatter inside SSW whether .NET 5 was the right name or whether it would have been a better name to go with .NET Core, 6, 7, whatever. So with that, I'm going to hand over to Brendan. Okay.
Good to go? Okay, good to go. Thank you. Okay, well, my talk is on the 5 important questions about .NET 5.
Can you share
and I'm
screen
going to start
first?
by, I believe I am. Check that with me.
Hold on, we need to have your screen coming through.
Let me. I'll reshare it. Sharing content. That screen.
I can see it here, Raj.
You can see. I'm waiting for confirmation.
Yep. Hold on. For some technical notes for people, Raj is using NDI in Microsoft Teams, new feature in there, and it should be giving us a nice output to his video streaming stuff, which is called Livestream Studio. And we are good to go, Brendan.
We're good to go. Thank you. So let me start again for the video and recording. My talk is called The 5 Important Questions About .NET 5. And to start, I'm going to introduce myself. And the first thing I'm going to do to introduce myself is to share one of my favorite Douglas Adams quotes. And Douglas Adams was a science fiction author in the 1980s. And he's really famous for having some really short but really pithy quotes. And one of these quotes is, "I've come up with a set of rules that describe our reactions to technologies. Anything that is in the world when you're born is normal, ordinary, and just a natural part of the way the world works. You accept it without question. Anything that's invented between when you're 15 and 35 is new and exciting and revolutionary, and you can probably get a career in it. Anything that's invented after you're 35 is against the natural order of things." Coming back to point 2, well, this is certainly true for me. The thing that was invented for me in this time was the internet and the World Wide Web, and I built a career on it. So I became a web developer in 1999, and back in those days, the way I did it was on Linux servers. So we started off writing Perl scripts or using PHP, and then later moved on to Java, and built quite a lot of websites that way. Then in 2004, I moved to Australia, started getting into .NET. And a few years later, ended up at SSW. I've been using .NET Core, as Adam said, since the early days when it was changing quite a lot. And some of my favorite things are Azure and still Linux. And one of my favorite things about .NET Core is the Linux support. It allowed me to kind of reunify the two halves of my experience, so to bring .NET Core and Linux together. Most of my day job, I am a solution architect, which means I spend most of my daytime at client sites or now working from home because of the virus, helping clients build awesome applications. And every now and then I get out from doing that to be a speaker. I speak at these type of user groups. Sometimes I'm privileged enough to speak at NDC. And I'm also a speaker at a couple of the Superpowers training courses that we run at SSW. Another thing to get going before we start, SSW have an awesome rewards app. I'll leave this QR code up for a little while, but scan this with your phone and you can claim rewards. Now, how do you gain these rewards? How do you gain points? Well, what you're doing right now is what gains you points. Interacting with SSW people or watching SSW talks, you will get a QR code at the end of the talk. If you talk to an SSW person, you can ask them for their QR code. You scan that, you gain points, and those points go towards prize draws and prizes. So let's move on to my agenda. And I've got a few sections here. So the first question, how did we get here? That's really about the history of .NET and how we got to the current state of play. Then we're going to look at two, that's got a general background. Then we're going to take it very personal. What does it mean for me and the type of project I might have to change now that .NET 5 comes out? So I'm going to ask about what about my .NET Core projects? What about my .NET 4.x projects? And I'm going to pause here to introduce a little bit of interactivity. Obviously, in person, we can do a show of hands, but that's not available to me. So instead, I'm going to do a show of Twitters. So I'm going to post this Twitter poll. It's tagged with .NET user group, where you can find it at Brendan SSW. I'm going to hit tweet on this now. And the question, my first question I'm going to ask today is, what sort of project will you plan to move to .NET 5? Do you have a bunch of full framework 4.x projects to move, or are you currently on .NET Core? So let me tweet that, and we'll come back and look at the results a little bit later. So back to my slides. Once we've talked about two different types of projects to migrate, we've got two sections. One is what's new, and this is quite big. This is I kind of run through my top picks of what's new across the whole stack for .NET. So we're going to include .NET, ASP.NET Core, Entity Framework. There's loads of new stuff. There's not enough time to cover everything that's new. So I've picked my favorite things, the things that I think impact me the most. And then finally, in what's coming, we talk about what's around the corner. So let's start at the beginning. How did we get here? So let's start with some history. In 2002, Microsoft released the .NET Framework version 1. And I'm labeling this the Stuff You Sun Microsystems Edition. So how did .NET come to exist? Well, before .NET, there was a language and stack called Java. And Java became popular with business programmers for a couple of key reasons. The main reason is that Java runs inside a managed memory framework. So you write code that compiles to bytecode, but that bytecode doesn't run against the raw operating system or the raw systems. It actually runs inside a virtual machine. And because it's inside that virtual machine, it means you can manage the memory. When you're writing C++ or C code, if you create a resource, you have to remember to manually unallocate that resource later. If you fail to unallocate that resource, you get what's called a memory leak. This piece of memory in your computer doesn't just stays there being used, and you can eventually fill up your entire memory of application and make your application crash. So the way I see it is, if you're writing a games engine, what you care about is it being fast. So you'll write your code in C and make it as fast as possible, because not having a garbage collector is definitely faster. But if you're writing a piece of business software, you care about it staying alive. You want to run a program where you start it running on Friday on a Friday afternoon, come back Monday morning, and it was still running. That's the kind of programming that managed memory is for. You're sacrificing some of the speed for much more reliability. So Java was out there being used, and Microsoft made their own products on Java as well, made some code on Java. But what they did, unfortunately, is they extended Java to add features and still shipped it with the label Java. Sun got very, very upset by this. The lawyers got involved, and so Microsoft backed out from doing Java and had to fill the same void with something else. And that's where .NET Framework was born. So .NET Framework is very similar to Java in that it runs on a virtual machine and has managed memory with garbage collection. So time went on, and .NET Framework 1.1 came out, which was a real sort of solidifying of the APIs. And the big change here is that .NET Framework shipped with Windows. .NET Framework became a fully supported part of Windows, and that will actually become important a little bit later. So when .NET 1.1 came out, it was some extra libraries, extra APIs on top of the core platform. .NET Framework 2, that was when we got a brand new full stack of .NET Framework. And this is when we added generics and other new features. The interesting thing here for me is right now, at 2006, .NET and Java are neck and neck. They're pretty much the same year. They released support for generics, the ability to have typed collections, and the syntax was very same. The syntax was mirroring .NET and Java were kind of neck and neck. If you were a .NET developer around these days, one of the most interesting places to be was in the alt.NET crowd. Because in the alt.NET crowd, what was happening is the Java world was iterating much faster on dependency injection and continuous integration, so automatic deployment. So what the alt.NET crowd did is they would port Java programs to C Sharp and run them. So for example, around this time, I was using programs like NHibernate, a port of Hibernate for an ORM to do database management. I was using Cruise Control to do continuous integration. And I was using Spring Framework to do dependency injection. So you wanted to use those things that were still, not quite there in the .NET world. You could do it through this alt.NET movement. In 2006, we got the .NET Framework 3, and that added WPF, WCF, and WF. And once again, this is extra libraries on top of the core .NET 2 runtime. And for me, when .NET really accelerated forward was the .NET Framework 3.5. Because with the .NET Framework 3.5, we had the addition of LINQ. And the biggest thing for me was the Lambda expressions you can do on LINQ. So strongly typed function calls and code that's strongly typed that forms expressions, which you can use to do a lot of things. So back in the Java world, they're starting to get this stuff now, but way back, all that alt.NET stuff, all those previous iterations of NHibernate configuration in those worlds was done with XML. And XML files get really big and really clunky until I've worked in Java programs where I had more XML than Java code. And the XML, we are supposed to configure the Java code. Time I set up my dependency injection, time I set up my data, my object to database mappings, it was getting crazy. So what you can do with LINQ and Lambda expressions is it's a way of attaching configuration to strongly typed objects without having to use either attributes or XML files. And that really took off for me in .NET, and that's what made, for me, this is when .NET hit the accelerator pedal, where Java started moving more slowly. In 2006, we got .NET Framework version 4, a few more features in there. And 2012 is one of my favorite releases because that's when we get async await. Now, when I first saw async await, I thought, there's no way I'm going to work with this. I can't see myself ever getting my head around this. And now I can't see myself ever writing code without it. So definitely went full cycle from what is this to it's the way forward for me. And since then, we have not had any huge changes in .NET. There've been iterative improvements, but no massive big ticket changes. Of course, there have been changes and improvements, but nothing big enough to make it onto this slide. Okay, so we're up to 2012, and we've got this .NET framework. It's been continually improved all the time, and then we hit the brakes and decided to do a complete rebuild into this thing called .NET Core. So why .NET Core? Well, for me, the simple answer here is Azure. Microsoft were hosting more and more tools and features on Azure. A big proportion of Azure is on Linux, and Linux does make a great choice for running small, fast servers. The great thing with .NET Core is it's cross-platform and it's open source. And if you look at the classic .NET framework, I think there was just way too many bought libraries, patent disputes, for them to take the existing .NET framework and make it open source. So it was much better to just let's restart the whole thing and launch it. And I think it was the right choice because there's no way you could have made it the next version of .NET because it wasn't compatible with .NET. So by making it .NET Core, saying this is something else, you had the time, and it's taken them the years till now, to build something on a different stream, get it up to speed, and now we're getting to the point where we can start thinking about the future. So a quick run through what was new across the versions of .NET. Well, .NET Core 1, that was really built around web and console apps. So the things you could do with the early versions of .NET Core was quite limited compared to the full versions of .NET Framework. But for me, what I cared about was .NET and console, web and console apps, ASP.NET in particular, and getting them small and fast and booting them into Linux server. So I was totally happy. But another key thing you get here with the .NET Core 1 is the underlying runtime, the underlying framework that has stayed throughout .NET Core. So we're talking about CLI first tooling, where previously in .NET, it was notoriously bad for doing anything that wasn't using Visual Studio. So the very first time you wanted to bring in something like continuous integration, so actually build your code automatically and have it deployed to a server, the first few times you attempt this with the .NET Framework stack, it was next to impossible. You ended up having to pull various DLLs out of the Visual Studio tooling and stick it on a server, and you weren't sure if you were allowed to do this, if it was breaking any rules. So now with .CLI-based tooling, it means the barrier to entry is removed. You don't have to have Visual Studio to work with .NET, and it's much easier to script up and automate .NET behavior. We've got improved CS proj files. So the very base of your application is that project file that tells .NET where your files are and where to go. And previously in old .NET, you had to have a huge CS proj file where every single file you wanted to compile is listed out. Now it's much more improved and it only contains configuration that you need. We've got the introduction of Net Standard, which I'll come to on the next slide. And we've also got things like ASP.NET Core. And building on top of that are lots and lots of Microsoft extensions library that if you pluggable ability to pull in different things, like the configuration engine is way better than it used to be. The ability to put in JSON behavior. And on top of that, we've got support, fantastic support for things like Azure and Docker. Because .NET Core runs on Linux, you can put it into small Docker containers. So let's go back to Net Standard, because it's an important thing that we'll look at later. So what Net Standard is, it's a formal specifications of .NET APIs. So what it essentially is, it's a document that says, if I'm support this particular version of Net Standard, I can run on these particular systems, because Net Standard lists out the bits of the .NET framework you can expect to be there for that particular standard. I think I explain it better if I show the slide. So this slide here has, going across the right at the very top there, all the different versions of Net Standard. So if I release a DLL or a NuGet package, and that NuGet package is at Net Standard 1.6, it means I can't run that on .NET Framework 4.5. I can only run it on 4.6.1, and that's after installing a patch. If I release .NET Framework 2, then I can only run it on Xamarin Android 8. So .NET Standard isn't a technology in itself. It's a common specification that all these different versions of .NET meet. And it means that if I write a library and that's what I target, it declares that that library can then run on that particular platform. An interesting thing here is already, so even before we're talking .NET 5, with the version of .NET Core 3, that's when .NET Framework stopped keeping up. So there's stuff in Net Standard 2.1 that .NET Core can do, but .NET Framework can't do. So we've been looking at .NET Core 1, carrying on our history with .NET Core 2. The big ticket thing here for .NET Core 2 is increasingly good support for ASP.NET Core. So much more features. What it can do is still serve web applications, but web resources, but how it goes about it is getting massively updated. So we have things like endpoint routing, a complete overhaul of the configuration of how you map an incoming URL to a piece of activity. You've got a brand new UI tool called Razor Pages, which is basically the best version of MVC they've ever made, even though MVC and REST APIs are really one of the things most people build now when they're using Java applications. If you do want to build a kind of server-side rendered Razor system, Razor Pages is the best one yet. We've got things like SignalR added to .NET Core, which gives us, I'll cover a bit more about that later, but that gives us true bidirectional data communication between client and server. And we've got things like the SPA templates. The SPA templates let us run our React or our Angular applications inside a .NET application. And with .NET Core 2, we also had Azure Functions came in. So you can write Azure Functions, which are small pieces of kind of Azure run on-demand code. And that on-demand code can now be in C# using based on .NET Core 2. Then moving on to .NET Core 3, the big ticket here is really moving in a lot of the stuff that was missing from the earlier versions. So from the earlier versions of .NET Core, you could not make WPF, Windows Forms applications. But when .NET 3 came out, you could. Some other things you can do is now on Windows, you can make COM components. So that's an important thing to insert behavior into Windows. You can run and build those in COM. Obviously, those are Windows only features. And just so Linux is not left out, ARM64 support appeared here for Linux. And this is interesting because ARM64 support in .NET Core came for Linux first, and it's only .NET 5 that will have ARM64 support in Windows. And once again, every iteration of .NET and .NET Core has huge improvements to ASP.NET Core across the board. I would say ASP.NET Core is the primary client still of .NET. And so every time there's a release, there's a huge swathe of improvements. So to help visualize the current state of play, I've plotted out a bit of a timeline with a whole bunch of things on it. And something else I've added to this timeline is the Mono framework. So what I want you to see here is the .NET Core hasn't been around that long and isn't going to be around that much longer. It's got a pretty short but beautiful history, where a .NET framework has been going on for nearly 20 years. And what's interesting is the Mono framework has been running for almost that long. So Mono existed as a thing, and it was just a kind of open source clean room implementation of the .NET libraries to run that on Linux. And what was happening with Mono is it would always be sat quite a way behind the .NET framework, but eventually after a couple of years get most of the APIs in place, but the level of support was much lower. But it was an ability to write C# code on Linux. It was always a slightly controversial project because there was always the fear that Microsoft would take offense and try and shut it down, not through copyright because they were doing a clean room implementation, but maybe through patents. There were patents that Microsoft owned related to the .NET framework, and there was a fear that the Mono project would be shut down because of those patent concerns. Well, halfway through that timeline, you can see the adoption of Xamarin. So that's really when Mono lifts its game to run not just on Linux, but onto mobile platforms as well. And that ran for quite a while until Microsoft finally saw the light and realized instead of competing with this Mono thing, that's the best way of getting .NET code into mobiles right now, let's embrace it. So finally in 2016, Microsoft bought Xamarin, and that's given us the thing today. So there's a reason I've got all three of these on board. There's a couple more things to show you as well. A few more pop-ups. In 2010, that's when Azure really started. So Azure's been around quite a while now, but that's had a huge impact on how Microsoft does its business because it's moved Microsoft away from being, we need to sell this software, to we are selling services. And it's a very different approach to how you license your software if the software is there to help you sell services rather than the software being the thing you sell as for profit as a sort of primary step. Then in 2014, the kind of precursor to the whole .NET Core open source thing is the .NET Foundation being formed. Okay, so here's the current state of play. We've got 3 versions of .NET sitting on this timeline. So let's talk next about the one.NET vision. Now, I've seen quite a few talks from various Microsoft people, and they've got a common set of slides they use to present these. So I'm going to show you exactly those slides and explain it in the same way. So the one.NET vision is we're taking these 3 versions of the .NET framework and we merge them into one. So we have one.NET, a single SDK, single software development kit with one base class library and a unified toolchain. So the vision goes further to show .NET 5. So what we've got here down at the bottom is .NET 5, the platform that runs all this stuff. And then underneath there's kind of compilers and languages. Right there on the right, we've got some tools. So we've got Visual Studio for Mac and Visual Studio Code. The idea here being you can use any of these tools as well as the command line interface and any text editor to build .NET, then any of these use cases. And the use cases across the top are desktop, web, cloud, Azure, Xamarin, Unity, IoT, and AI. So pretty bold. Take one.NET to rule them all, one.NET for everything. The thing to keep in mind when you see these 2 slides, both this slide that shows one.NET, the kind of 3 being merged to 1, and this showing one.NET, a unified platform, is what you're looking at here is the .NET vision, the .NET vision for the Microsoft's vision for the future of .NET. Unfortunately, the reality isn't quite that yet. So let's see what we actually do get. So we've seen the vision. What actually is .NET 5 at a low level? Well, actually, .NET 5 is pretty easy to make, because what you do is you take the latest version of .NET Core. Now, the latest version of .NET Core is brilliant. I love it. But what you do is you take that version of .NET Core and you slap a badge on it and call it .NET 5, and then say that's to avoid confusion. What's interesting about this state of affairs, and we've had various discussions about whether it's a good name or a bad name, and I'm slightly on the fence. There's some good things and bad things about it, but certainly what I'm not unhappy about is the fact that .NET 5 is .NET Core, because .NET Core is awesome. And just to double down on this point, you can see that .NET 5 is .NET Core, because if you go to the .NET Core GitHub page and open up one of the projects, you can look through the version tagging. So this is where they're tagging the source code to say this is the code we're going to package for that release. And you can see down the bottom here, we've got version 3.1, version 3, preview 1, preview 2, preview 4. All those version numbers are just tags on exactly the same code base. So there's a whole bunch of files in .NET 5 that are exactly the same files as they are in .NET 3.1. It is a version increment on an existing project, not a new project. But that is exactly what I want, because I love .NET Core. Naming or anything aside, I am totally and unironically happy about .NET Core, .NET 5 being .NET Core, because I love .NET Core. So let's break down this vision a little bit more, because we're not getting exactly that unified thing yet. So what are we getting? Well, let's first talk about .NET Framework. So the phrase Microsoft used here is Microsoft Framework is not dead, it's done. So what do they mean by that? Well, Windows XP is considered to be dead. If you were to contact Microsoft and say, hey, I've got this security bug with Windows XP, they would say, no, out of support, we don't support it. I think there are a couple of deals with some particular providers, but I think what they've got is access to source code and the ability to patch it themselves if they need to. So what does it mean? Well, .NET Framework is not getting any more updates. By updates, I mean new features. It will get and continue to get security updates. And one of the key reasons for this is the .NET Framework ships with Windows. So the lifetime of support for .NET Framework, because it ships with Windows, is the lifetime of the support for Windows. And there are no plans to remove from Windows. So an interesting fact here, because of that, is Windows has an extremely long support time. So I'll talk more about the LTS editions of the framework later. But what it does mean is .NET 3.5, for example, will have a longer lifetime of support than .NET 8, which is years away. So that's an interesting fact. So what that means is if you are on .NET, it's not going away anywhere. The stuff you've got will still work, it will continue to work, and it will continue to be supported. But where the new stuff is, where the new features, that is .NET Core. So .NET Core is the future. We'll cover that in much detail later. So what do we do about this block here, this Xamarin block? Well, this one I've labeled, it's complicated. Lots of ins, lots of outs, a lot of what have yous. So let's take a look again at this .NET Unified Platform. And when it comes with the question of, okay, what in this unified platform is there and complete and ready, I'm happy with all those things. The gray area for me is this middle bit that's based on Mono. So Xamarin runs on top of Mono, and the Unity framework for gaming runs on top of Mono. So I asked a really simple question a couple of weeks ago when I started researching this, because I can't claim to be a Xamarin developer on a day-to-day basis. And I thought, well, if Xamarin does run the .NET 5, which some of the early kind of statements seem to imply would happen, that's pretty big news. So does Xamarin run under .NET 5? And it took me quite a long time to work out the exact answer here. I started by looking at the latest copy of Visual Studio and trying to create an Android project. That didn't really tell me much. There is nothing when you click one of these Xamarin things, it says it runs on Xamarin. That doesn't tell you what that Xamarin is running on top. So when they do finally switch, that's not going to change there. Eventually, when I did create a project, I could look at the project file, the CS proj, and see it didn't look that much like a .NET Core project. And I also finally saw the word mono, but I didn't really get confirmation until I saw this video, and it's a short one, so I recommend everyone watch this at some point. But I hope I get his name right, Imo Landworth, who's a program manager for .NET. And in this one, he clearly explains that Mono is the full Mono integration for .NET 6 is planned for .NET 6. So one thing you'll hear coming out of Microsoft and Microsoft developers and anyone explaining .NET is you'll hear talk of what's called the .NET 5 to 6 wave. Sounds great, doesn't it? Like you're waving, like you're you're surfing a wave into an optimistic future. But what is the .NET 5 to 6 wave? Well, this is the true vision of .NET. So right now, .NET 5, you've got .NET 5, which has a lot of new features on, a lot of new stuff, but you don't have that fully replacing what Mono does for the Xamarin Toolkit. But with .NET 5 to 6 wave, that's when you get the single SDK with one BCL unified toolchain, your cross-platform native UI, cross-platform web UI, cloud-native investments, and continuing improvements in speed and size. But for me, the big thing to overcome is that cross-platform native UI, the stuff that currently Xamarin does, getting that running on top of .NET. So one final piece in that puzzle was Unity, and I couldn't find any official announcements by the Unity team on their support for .NET 5. I found this blog post where someone said, "Oh, we're just going to wait until it's out and then start looking at it," which isn't a terrible thing if they're planning on keeping up to date in various other ways. But certainly most people can see that .NET 5 would be a massive boost for Unity, certainly in its performance and its getting those modern product stack with those modern project files and that kind of stuff. But I think the current sort of state of play is it's being worked on, but there's no official announcement yet. So hopefully that'll change quite quickly once the once .NET 5 is fully released. But the thing to remember here is Unity is not owned by Microsoft. It's built on top of Mono, and it's its own beast. They will, I'm sure they will eventually move across to .NET 5, but they'll do it in their own time, and they've got plenty of other things to worry about as well. Like their Unity does quite a lot, and they've got, to maintain continual updates of graphics cards and things like that. So there's quite a lot for them to do, as well as consider taking on .NET 5. So I think it will happen, but it'll be a while. Okay, so I think that's a fairly good introduction of how we are, where we are, how we got here. So let's bring it back to me. What does it mean about my my projects? So what about my .NET Core project, and what about my .NET 4.x project? I guess now is a good time to see if I've got any hits on my Twitter poll. Okay, so that's a pretty good result, and it immediately disappeared. So straight away we're looking at 13% on .NET Core full framework and 86% on .NET Core. Well, those people who are there on 86%, you're going to have a great time. Let's take a look at how to. So the first thing I want to do is take a look and do some code for these people, the .NET Core people, and show you what I need to do to take .NET Core project and migrate it to .NET 5. So because .NET 5 is .NET Core, this should be easy. Another thing to point out is the sub-projects, the child projects. They're the projects in their own right underneath .NET, such as ASP.NET Core and EF Core. Those are not being renamed. They're going to get a new version. They're going to have a V5 version in sync with the .NET platform, like they've had V3.1 or V2.2 versions in sync with with .NET Core. But they're going to keep their core names. And that's interesting because I think that's the right move, because they're not changing significantly and they're just getting version bumps. And these are projects in their own right. There's I like to have this separation and to make clear this separation between .NET, the tooling and the platform, and these projects on top of .NET that you can pull in as a NuGet package that then gives you the ability to do stuff. So in most cases, for upgrading a .NET Core project to .NET 5, it's just a version bump in your CS proj file. So let's take a look at a real one. So here is a CS proj file for a project myself and William Lieberberg have worked on. It's this is the web. This is an admin portal, part of a larger web application. That this gives people a UI that lets you look at messages that are flowing through an integration platform that's built on lots of function apps and moving kind of data between related services. So a way to visualize this is to jump out to the source code control and take a look at the in-file changes of that one. And what you can see is there's a few changes here. At the top, there's this thing called target framework, and that sets what version of the framework you're planning to run on. And where it did say Net Core App 3.1, I changed this to Net 5. The next thing I did is I searched through the list of packages. So you can see I'm using a few packages here. And the great thing about the new CS proj files is mostly the thing in here is a bit of configuration for special things about files, and mostly your package sources. So you don't have a packages.config that's set out externally now. It's a core part of your application, core part of your project, what packages you're using. And you can see I've got a whole bunch highlighted here, and these are the ones that start with Microsoft.ASP.NET Core. So I've got a URL that's about authenticating with Azure AD. I've got a package. I'm bringing in the Newtonsoft JSON package. I'm bringing the Sparse Services package. So what you do is you run through this list of dependencies, and you change where it says 3.1 or 3.0 to the latest version, which at the moment is 5.00-RC2 and loads of numbers. We've got a huge lot of numbers here because we're still in preview, and that's the current version. That will change to 5.0.0, probably 5.0.1 quite quickly after that. But that's the change I did. I then compiled it, and it worked. That is the application migrated. So this particular project had very little work to do, but of course your own mileage might vary. And the thing to watch out for here, the same thing that's always an issue is your dependencies. So one thing to help you here is there's a big list of breaking changes. They make these breaking changes for all the .NET, the version. I'm sorry, I'm just trying to scroll a screen grab. Sorry about that. But if you look down the side here, you can see there's changes from 2 to 2.1, changes from 2 to 3. So the 3.1 to 5 is just another in that list of change sets. And there's a few changes there. You might have something now that you hit. So definitely the thing to do is immediately after you've made that change is test it. You need to thoroughly test your application before you migrate. And then you need to thoroughly test your application after you migrate. And don't throw in some code and feature changes into the mix, because then it's confusing. Was it this new feature that broke it or this code change that broke it? So once again, test before, change your dependencies, test again. Then when you're happy, you can start making new features again. Wow, that was short. That was not much work at all. So pretty good. .NET Core projects, we're good to go. So what about my .NET 4.x projects? Well, that's where it gets a little bit trickier, because if I want to take, for example, a .NET web application and convert that across to .NET Core, it's not really an update. I can't take the project as it exists and just run some tools on it and then have it upgrade. There is fairly recently released an AWS tool that claims to be able to do some of that for you, but I've not tried it out. I'd be happy to hear someone give it a go, but that does have some tooling to help you. But certainly from my experience, there's no nice process to do this. There's no breaking changes document that says, oh, here's the 5 things that might be broken, because the entire stack is different. So what can you do if you are on a .NET full framework project? Well, one thing I want to point out is there are always options. If you're on an old project and it's too hard to move it off being an old framework, you can still refactor it to be nicer. You can still refactor it to be more modern. You could, for example, keep full framework on the back end, but introduce a nice modern JavaScript API on the front end. Maybe you start migrating some of the endpoints to being REST APIs instead of being Razor pages, And then before you know it, it's much easier to migrate your system across. But generally, there's always some way to make it more modern. At some point last year, I was working for a few days for a client, and they had an ancient .NET Nuke site. So we're talking circa 2009, 2002, 2004 version of .NET Nuke, and they were still building their app with that. And that's all built on top of web forms, and .NET Nuke is quite an opinionated framework that lays things out in certain ways. And so I found it quite a struggle to go back. I've worked on .NET Nuke before, and I was finding it quite clunky to work with. But there's always options. So I thought, well, how about this is a very interactive screen. I want to make it more interactive. The way you would have done that in the .NET Nuke days would be through there was update panels that used Ajax that were quite slow, or with jQuery. But what I found is I picked Vue, and one of the great things about Vue.js is you can run Vue.js as a whole kind of compiling JavaScript server with a Webpack file, and write TypeScript and compile it to minimize JavaScript. But you can also pull in Vue.js just as an inline library, like you used to do with jQuery. So I pulled in Vue.js, and then on the server side, I added a ASMX file, I think it is. So that's the old technology in web forms, where you can have a endpoint in your web forms technology that acts as a service rather than rendering a full Vue.vue, and in this case, controls and ASPX. You can render just a JSON instead. So with those two things in place, I was very quickly writing code, even though it was inside the .NET Nuke framework, that felt like a modern application. I was writing JavaScript with JavaScript, data binding on the client side, and I was posting web requests to a web service, and the web service was taking those requests and putting them into the database. And so there's always an option of something you can do to make even the oldest of applications feel modern, feel new, and feel like you're more productive. Something else you can do here is Entity Framework 6 can run on .NET Core. So the latest version of Entity Framework 6, I think it's 6.13, something like that. They actually upgraded it to be net standard compliant, so it can run on top of .NET Core. So what that means is you might have an old application where it's based on EF6, and that EF6 data layer has been around a long time. It's going to take a huge amount of work to change how it is. It's got years and years of business logic put in there. We're happy with it. We could be faster, but it's what we've got. It's what we need to stick with. Well, now you can take that data layer and run that on .NET Core. So you get the benefits of .NET Core performance on the web side of things, but then it just passes those requests through to EF6 to perform your data access layer. So you've got EF6 added as data access layer, .NET Core on top. So you've got plenty of options. And I'm going to show you one option to migrate an application from full framework.NET to .NET Core and .NET 5 right now. So I'm going to start by showing you a very simple application. So this application is very simple. What I did is I created a standard ASP.NET MVC project. I created a couple of views and a controller. And the controller I've got is called Weather Controller. And it's one of those classic examples. I've got a free weather API here. So what I'm going to do is I'm going to have a screen where I type in a city. It's going to perform a search against Open API Weather Map. It's going to give me some data back. I'm going to pass that data and rip out a description of the weather and a temperature. So let's take a look at that running. So here I have an ASP.NET application. Let's resubmit the form. Let's change it to Brisbane. Now, the observant among you will have noticed that the temperature's been delivered in Kelvin rather than centigrade. Either that or these broken clouds are of liquid methane. Okay, so there is my application. It's not the most complex application in the world, but it's enough to show you how to go about refactoring this to make it ready for .NET Core. So the first thing to point out is that all the logic of this application, the fact that I've got to make a HTTP client, the fact that I'm making a call to external service, it's embedded inside the controller, and it's embedded inside this .NET application. So this is the application that I have to change. I have to make a new one of these. So any logic that's in here has to be replaced. So what I want to do is start to break up this application so that the amount of logic that's in this controller is as minimal as possible. The job of the controller is to receive the requests and pass the details on to something else. So what I'm going to do now is I'm going to open a second project where I've started to do this work. Okay, so what I've added to this project is a library called application. And the key thing about this application, if I right click on it and go to edit project file, you can see that this project targets Net Standard 2. So I can make a project that targets Net Standard 2, and that means that this will use all the APIs and libraries from Net Standard 2. What I can't make is a startup project that targets Net Standard 2. If I want to start an application, I have to pick a framework to run that application in. So for example, this MVC web application, that's set to .NET Framework 4, 4.6 or 4.7. But this application targets Net Standard, which means this application as a project reference can be used by a full framework app, or it can be used by a core app. So once I've created this application, what can I do with it? Well, I need to write something that performs my weather request. Now, this can be anything. I'm going to show you a library called Mediator and how I've wired that up. But by no means, you don't have to use Mediator. So long as you have a way of saying, here is my input to my operation, there's the service, you can perform that service, that's fine. Why I like Mediator is it gives you a very clear and constrained way of defining your input as request objects and defining your responses and defining your handlers to do that. The other thing I like Mediator is its support for dependency injection. You can declare this is the handler that does the work, and you can separately inject the dependencies, which is what that thing needs to do that work. So let's take a look at that handler. So what I've got here is an object that represents my request. If I want to find out about the weather in a city, I need to feed in the name of the city. So I create a request object that says, give me the data for that city. And I can make this as complicated as I need to be. Then I make a handler. And this handler says, does the work. So this handler takes a HTTP client, performs a HTTP post, a HTTP get, gets the data. This is exactly the same code that was in my controller. I've just changed it. There's one quite interesting change though. In the previous full framework version, I was using system.web.http. What I'm using here is iHTTP client. And if we look back at the dependencies here, I've actually injected the latest version of Microsoft extensions.http. This is the exact same library that you'd use in your .NET Core application. Now, the key point here is these libraries support .NET Standard, which means provided your version of .NET supports .NET Standard, so it's 4.6.1 for a lot of versions, 4.7 for the latest, then you can use these libraries. So you can start using the new stuff that comes in .NET Core from the old stuff, and it works fine. So what I've done here is I have set up this application to now use the latest Microsoft extensions to HTTP. So when I look at this handler, it's using that latest version with the best practice of injecting the HTTP client factory, using HTTP client factory.create client. The framework from that code will manage the lifetime of my HTTP client much better than the versions you were getting from HTTP client. So that's created this application. How do I wire up this application, and how do I set up Mediator to know that it needs to feed me these HTTP client factory objects? So I'm going to come back into my application now. And so what I need to do is set up some dependency injection. So what we're looking at here, and let me explain that. This whether request handler does some work. And in order to do that work, it needs something. And that something is a dependency. The thing it needs is this reference, HTTP client factory. And so what happens with dependency injection is we declare that dependency as a constructor parameter right at the front of that handler. So it's not possible to create an instance of this handler without feeding it this HTTP client factory. That is the essence of dependency injection. So that's how I set up something that uses a dependency. Now all I have to do is do whatever it takes to set up that configuration so the framework will feed in this HTTP client when a HTTP request handler is required. So what I've done here to achieve this, if I look at the ASP.NET project for here, if I can find where that is. And I've lost the item that lets you open the file directly. I'll skip that then. But what I'll tell you is what I've done is I've configured. If I look at manage, let's have a look at manage NuGet packages instead. So if I look at my installed NuGet packages, I've installed a few more NuGet packages. So I've installed a mediator, which is what I need to do that mediator redirection. But I've also installed this thing, mediator extensions.microsoft dependency injection, which also brings down Microsoft extensions.dependency injection. Now that is the library you use in ASP.NET Core and .NET 5 if you want to use the new dependency injection framework inside ASP Core. But I'm telling you now, you can use that same library inside full framework.NET. So let's take a look at how we do that. The next thing to do is you want to run the configuration using that dependency injection. You need to run that on top of your standard classic.NET. Now in new.NET, you've got a fantastic startup file with a specific specific method called configure services just for setting this up. It's built for it. So what you need to do in your classic.NET framework is set up some code to do that operation, to do that work. Exactly how you do that depends on what you actually built inside .NET, because there's previous versions of ASP.NET Core. Web forms are slightly different to MVC, and then the newer API versions of MVC are slightly different. In fact, the old .NET had a problem where there was actually two competing pipeline stacks. One was the classic MVC controllers, the other one was the newer API controllers, and that's something that got fixed up in the move to .NET Core. So if I look in my application, there's this area called app start. And app start is a bunch of stuff that runs when the application starts. And I've created bundle config, filter config, route config. It's all standard stuff from the framework. I've created my own called dependency injection config. And in fact, the main config is kicked off by one of these. I can see which one it is. Oh, it's in global.asax. In global.asax is the actual application start, and you can see I've wired up dependency injection.setupdi. So let's take a look at that function. So what I'm doing here is this code looks exactly the same as what you do inside ASP.NET Core. You create a service collection, which is your dependency injection container, and the pattern that applies most in ASP.NET Core and Net 5 is if a library gives you a way of wiring itself up through Microsoft dependency injection, usually there'll be a library and an extra kind of side library to attach to give you this feature to wire itself up, is you get this extension method on top of the standard service collection services. So if you go services.add HTTP client, you wire in the HTTP client. Mediator is services.add mediator. You have ones when you're running MVC, and add the MVC pipeline, or services.add authentication. It's how most things are done. So this code here is exactly how you'd write it in .NET Core. So the only thing we have to do now is set up the classic framework dependency injector to use this dependency injection configuration. And to do that, we do two things. First of all, we need to run some code to tell the new service collection where our controllers are. So I've got a bit of code here that basically scans the assembly, grabs all the controllers, and then registers each controller as a transient type. So that means the new .NET Core Microsoft extensions to dependency injection now knows about my controllers. And then I insert. The next step is this little piece of work here, this Microsoft dependency injection resolver. This implements an interface called iDependency Resolver. That is the interface from old .NET of how to wire up a dependency injection. What we feed it is the new configuration and say, okay, when the framework from the old .NET asks me for a service, I'll feed you the service from the new .NET configuration or from the new configuration system. And it's that big. So with that in place now, I can wire up. This is kind of a small example, but I can take a whole chunk of configuration just like I would in my ASP.NET Core and make it work the way it would in ASP.NET Core. So with that in place now, I can now come back to my controllers, and my controllers themselves become much simpler, because what my controller now does is it takes in a request and I just feed that to Mediator. There's now no work being done inside that controller. So this is the thing that I'm going to throw away when I migrate, and it doesn't do much. And all I have to do is copy this into the new .NET, and away it goes. So let's start by running the application from classic.NET. Let's set a startup project. Let's go Control F5. Okay, there I am. I'm running that application, and if I go to weather, it's still running. Let's go Melbourne. Great, still working. So let's see what we've got. What we've got is we've still got a classic .NET full framework project, which is what we start, the web application, but most of the logic has been moved into this application layer. So all this does now, it's a startup project. So now I'm free. So you can take a while now. You can take your time to start moving features from being embedded in your .NET 4 full framework up to the application layer. And once you've got everything moved, you're ready to migrate. And at that step, the actual migration should be as quick and as small as possible, because what you then need to do is create a new project, you re-implement your controllers, and now we've got an ASP.NET Core project. What we need to do in this ASP.NET Core project is set up the dependency injection. And so basically you just cut and paste that same bit of configuration you had, but now it's going into the folder that's made for it. And if I run this application, and go. Obviously, I've copied across some views as well. You can see it looks slightly different. It's not the same application. But when we come to the weather controller, the actual code that executes the function of taking a city name and bringing me back a some weather data. Let's go Adelaide before I run out of city names. Again, that's still working. So what have we looked at? Let's go to a summary. So in summary, we looked at one possible approach of doing a migration from full framework.NET to ASP.NET Core. This isn't the only way you could do this, but it's a way I'd recommend because to my mind, what you end up with is quite a clean solution where the business logic of your application is moved out of .NET Core. And the other advantage of this refactoring is you might find that you have bits of your application that you don't want to run from controllers anymore. You might have some bits of your application that are HTTP posts. Some bits might move into gRPC or the SignalR requests. But once you've done that step of moving your logic into some kind of command query handler, you can use Mediator, you can use something else. But once you've separated out your controllers, which are in charge of network traffic, to your actual business actions in an application layer, it's so much easier to route things around. So the summary here is move app logic out of a web project. Make it so you can invoke commands and queries independently of UI. The operation to get the weather should be the same whether or not you invoked it from a HTTP call, whether you had a console app that wanted to do it, or whether you had a SignalR or a gRPC request. And once again, Media CQRS is a great choice for this. Something else to point out is you can start writing code that looks like .NET Core code that's using the libraries you use in .NET Core code on top of full framework, because those libraries support Net Standard. And as long as Net Standard is still the thing everything's supporting, that still works. So the key thing here is you do a bit of work up front so that when you make the final migration, the bit where you have to stop using the .NET Core project, so the .NET Full Framework project, and start thinking about your .NET Core or .NET 5 project, you want to do that as quickly as possible. I have seen some migrations where it was done kind of piece by piece, but it was done piece by piece by having two web apps. It was a JavaScript-based application, so it was possible to have half the endpoints running on one service and half the endpoints running on another service. The problem with doing this is you've got lots of extra things to double up. You've got to double up your authentication storage. You've got to double up your logging and your configuration, your production. So if at all possible, set it up in the old framework and then minimize the amount of time you're performing a migration. Some other things to point out is obviously this is quite a simplified example. The sample you're looking at here performs one fairly basic thing. There is no logging configured. There is no authentication configured. So there's quite a bit more to get working to bootstrap your application. But then the basic, once you always need to do that kind of basic bootstrap stuff. But the idea that you move your business logic or the things that you want your application to do so that they're not dependent upon the fact that you're running inside a web app, that's something that will always pay off. I have never once regretted adding Mediator to a project. And another thing to point out is us at SSW are for hire. So if you try to go through this migration process yourself and you want some direct and real pointers on how to make this work, because there's so many edge cases involved here, there's so many mixes of dependencies, and it's very easy for an app to become quite unique if with a particular mixture of dependencies you've added, then by all means, we are for hire and we can come in to take a look and help you through those really tricky kind of higher level approaches of where to move. Okay, so that was a couple of stories on how to migrate a couple of projects, .NET Core and .NET 4.x. So next section, we're going to take a look about what's new in .NET 5. Now, the key thing here is there is lots of stuff that's new. So what I've done is I've just picked out my favorites. So the first thing to talk about is tooling for microservices. To explain the pain, I've been working with microservices a little bit recently. And what I mean by microservices is small apps that are integration apps where messages are being fired from lots of different services. They're not my services, but they need to talk to each other. So I've got function apps that pick up messages and send them around. And I've got lots of little services to run. So if I want to run a test on my local machine, I've got to start up 4 or 5 services for working tests, which means either lots and lots of command line windows or lots and lots of tabs in the modern Windows terminal or the Commander terminal. So there's a new project called Project Tie that's designed to help with this. It's so new, there isn't a logo, just this GitHub page, and it's currently experimental. But let's take a look. I've got a little demo on how to use Project Tie. Just start by looking at the command line. Okay, so here is each of these blue folders is a service that's part of my application. I've got an admin portal that provides a web user interface. I've got a whole bunch of different services. There's something called Health Check service, and its only job is to fire out a request to everything else saying, are you okay? and then reading the response. There's a message store that kind of backs up all the messages that are sent around. There's the ability to talk to a Shopify instance and receive orders coming in. And so all of these services are part of my application, and they act semi-independently, like all good microservices architectures should. So if I wanted to start this by hand, I've got to create 4 or 5 or 6 tabs and step through them. What I'm going to do instead is I'm going to take a look at Thai. And the first thing I'm going to do is look at my Thai file. I believe it's this one. Here we go. In fact, I've already got it open. Now, Thai is a DevOps project. You can tell it's a DevOps project because there's a rule of nature that if you're dealing with DevOps in any way, you absolutely have to use YAML. I'm not a big fan of YAML, as you can probably hear from my tone of voice, but here is a YAML file for this particular project. Now, one key feature of Thai is its ability to configure itself. If you pointed at a solution, it will scan through the projects in your solution and set up its own configuration and start them up. Another thing Thai can do is it can take control of the independent communication between those. So if you have microservices that communicate directly with each other, I'm not doing that. I'm communicating with a centralized service bus, so I don't have to have direct communication between each of my applications. But if you do have, application A needs to know the address of application B, Project Thai can be set up to configure that for you and make sure the applications start with the right settings. Project Thai, I've created this file because I've got a few services I want to start, and some of these services are functions. So you can start a project just by feeding in the project file, and you can start an Azure function just by passing through the folder that function is in. And with that set up, all you need to do is go to the right command line and type Thai run. So what this does, this starts a little dashboard, and it starts that dashboard on localhost 8000, and then it builds all your projects. So bear with you while that happens. It will go to each of those projects in turn, build them and run them, and then give you details on the pipeline, on the dashboard. Okay, I think that's running. So if I come to the dashboard now, I think I've still got it here. If not, I'll open it. Let's do a refresh. Okay, so now I have a dashboard where I can see the running services, see which ports they're bound on. So if I want to look at one of those, I'll just click on it. But I can also see, this is interesting, I can see the logs coming out of each of those projects. So this project is very early days. It's in very early beta, but I'm already finding it useful. I've set it up for one of my projects, and I'm using it at a client site right now just because it's easier than starting up 50 different tabs. Or 50 is too many, but sometimes I've had as many as 10 running. Another thing to point out here is what I've shown you are 2 types of project this thing can start. And those 2 types are a .NET Core project and an Azure function. Another thing you can pull in are container images. So if you have an application that's containerized or a dependency that's containerized, say you want to run Seek to do your inter-process logging, or you want to wire in application insights, or you want to have a container that contains your database, then great, you can wire that up and it will start containers inside this same thing. The next thing it can do is it can take this configuration and actually deploy your set of applications and containers to Kubernetes. So it really is a full framework. It's early days, and I've just shown you a little bit of it, but it's got a huge amount of potential. It's definitely worth looking into. What else is new? Well, it's been mentioned before, but Blazor has got, I think, the most number of new feature and most number of items in the What's New pile. Blazor is really solidifying as an excellent choice, and as was said earlier, some of our clients have been using it, and it's been very well received. I'm champing at the bit to use it myself. I did some talks on Blazor really early. I've not had the chance to use it in full flame anger yet, but I'm sure I will, and I'm looking forward to that. Some new features for C#. So C# 9 has a brand new type. So where we've currently got classes, struts, and enums, this brand new type is called a record, and it's an immutable reference type. So we've had immutable value types before, such as struts, but the problem with struts is when you pass them into a method, it does by value referencing, so it actually copies it. Record types are immutable reference types. You pass by reference, but they're still immutable. You shouldn't change them. I can't change them. So why would I want this? Well, for me, the real useful bit for this is shared data in async programs. I've done a bit of work with Angular, and I'm kind of loosely aware of React Redux, but in Angular, we have an implementation of the Redux pattern called NGRX. There's another one called NGXS, and it's all about shared data in an asynchronous program. The idea here being an asynchronous program has events that fire off all the time. It's very hard to keep track of what's going on. So you tightly constrain how your shared state gets changed. And when you're dealing with the Redux pattern, a key point of the Redux pattern is that your core records, your core state, is built out of immutable types. So having explicit support for immutable types, rather than having to write quite a bit of code to create a class that's immutable by itself, is great. But you also get some other stuff. If you want to find out more about Redux in Blazor, which is where it's also very useful. So the Redux pattern is something in JavaScript applications like React and Angular, but Fluxor is the same concept applied to Blazor. And we've got an awesome talk here by Chris, also attended by JK, Gabriel, and Adam, that will introduce the Redux pattern in Blazor WebAssembly. So the thing to Google there is Fluxor, Fluxor, and SSW. You'll get this video. Something else about these record types, they do a few interesting things. When they compile, they'll compile an equality operator. So you can go put this person equals that person. It won't go by object reference. It will go by comparing values. They also have an auto-generated clone method. So things that you would have to write yourself if you wanted to build your own pattern for this in C# 8, you get that generated for you with the C# 9 record types. Next new feature is top-level statements. So this really attacks a very common bit of ceremony when we're creating a new application. So on the top half of the screen, you can see the smallest possible .NET application. It's got a using statement for system. It's got a hello world namespace, a program. It's got a static void main program with the args declared. And finally, after all that, you can write a bit of logic, which is console.writeline. Well, with top-level statements, you can throw away all of that and go straight for system.console.writeline. You'll notice that it starts with system.console because we've skipped the using system. Because we've skipped the using system, we have to actually prefix our command with system, but it's now possible to write a single line application. So this is where this is really useful is I think we're going to start seeing a growth in C# as a scripting language because of this. We've seen a few things like CSX, but I like C# and the syntax so much. I think C# will make a great future for a cross-platform scripting language because I know I've tried PowerShell on Linux, and you know what? I really liked it. I was expecting to, but I did. But I'm still not a huge fan of this PowerShell syntax. It's almost what I want because it is definitely better to me than the bash scripting we've had on Linux for a while. But if we have a C# based scripting that's cross-platform and running everywhere, that's going to be what I'm going to write everything in from now on. So hopefully we get that. Single file applications. So the idea here is we can compile our application, which is usually lots of files, to a single file. The idea here being it's easy to deploy, you just got to copy one file around. And single file applications can be set up for both framework dependent and self-contained. What do I mean by that? Well, a framework dependent application requires the .NET runtime to be installed on the machine in order for that program to run. Self-contained does not. Self-contained packages enough runtime stuff with your application to run just by itself with no framework on that machine. But obviously the self-contained it's guaranteed not to have any problems. Like if it was built for a different version of the framework, that's fine, it ships with the framework. But the downside is that particular deployment is bigger. But if you're building a Docker container where the whole point of that container is to run that program in a container somewhere, then why not remove all the framework dependencies and just make it self-contained? There's a few more features related to this, and these are switches on how to compile your application. And you'll be forgiven for recognizing these if you've done any JavaScript work recently. There's a feature called Ready to Run, which is actually performing AOT, or ahead of time compilation. So that's more about pre-compiling certain resources in your application. So the application is a bit bigger, but starts faster. And then trim. So people have recognized trim in the JavaScript world as tree shaking. The idea here is that I've built an application, and that application uses some libraries. So what you currently do if you use a library in your application is you ship the DLL of that library with your application, but you might be using just a small fraction of the features in that DLL. So what you can do with the tree shaking is you run some analyzers that work out what you're not and what you are and are not using, and then minimize your application. It's an experimental feature right now because there are certain things that don't work very well with it. If you're using a huge amount of reflection, the tooling can't tell what you are and aren't using. But if you're not using huge amounts of reflection, then you can run this trim feature and have your code shrunk down. Where the huge impact of this applies is on Blazor, where you're having to ship a .NET with your application to run inside the browser, inside WebAssembly. Tree shaking it down and trimming it will mean your initial download of your Blazor app will be much quicker. And finally, potential opportunity for single file applications is the much aligned right-click publish could become drag-drop publish. Now, ASP.NET, as I've said before, is pretty much the prime citizen in the .NET world. It's the first thing people look at, it's the first thing people use .NET for, and it's the thing that has the most attention provided to it. So there is a huge amount of changes recently across all the release candidates, across all the previews. And so I am not going to show you all of those changes. I'm going to pick out my favorites. So first off is support for OpenAPI. So OpenAPI is a way of specifying your JSON REST APIs. So cast your mind way back to the XML days, there was this concept of service-oriented architecture. The idea being you published web services, and those web services had a WSDL file. You could hit that WSDL file, and it would give you an XML document that would describe the operations you could call on that service. So a lot of that was lost when we threw away XML for JSON, and it's OpenAPI, previously Swagger, that brings it back. So one great thing about this tooling is it not only gives you a specification, it gives you tools that can read that specification that can give you this documentation. So this documentation we're looking at here is an interactive web interface that you can read to look at what operations you have. You can also click on it, drill into requests, and actually submit requests from this application in order to test your API. So how is ASP.NET Core supporting this? Actually, next thing is, here is an example of an API specification. So it's a JSON document that describes the various details about your API, what the endpoints are, what the main host name is, the base path, what are the objects you can send, and what are the objects you expect to receive. So OpenAPI support has been around for a while in .NET Core, but the big change here is it's now on by default. So Swashbuckle is being delivered with .NET Core. So if you create a new .NET Core project now, and it's an API project, it will include Swashbuckle that configures the auto-generated APIs. Some of us at SSW are on Team NSWAG, which is another library that does the same. I'm assuming this does mean that NSWAG is going to become less popular, but right now I'm still fond of NSWAG because NSWAG has some features that Swashbuckle doesn't, mainly the generation of JavaScript clients for your API. And for me, one of the key things of a REST and JSON API isn't talking to .NET servers. You got other alternatives for that. It's for talking to things that aren't .NET, giving you this low common denominator that everyone can target. Some more features is there's the ability to import your OpenAPI configuration file directly into Azure API Management. So Azure API Management is kind of a managed proxy service that lets you much more tightly control the different endpoints and the security of the endpoints coming into your application. You can introduce things like additional security. You can actually protect your APIs with OAuth. You can also introduce things like protection against load attacks and those kind of features. So the difference here is when you create an Azure API management setup by yourself, you have to manually plug in all the different endpoints to support. If you're using OpenAPI, you can feed the OpenAPI configuration to Azure API management, and it'll wire it all up for you. Finally, you've got improved tooling from the Visual Studio. So you can just right-click Add Service and browse to an OpenAPI, and it will generate a .NET client for you. Microsoft Identity.web is basically adding support for the Microsoft Identity platform. And on Azure, it's the identity platform that's kind of moving in front of Azure AD and Azure B2C to give you a common experience across both Azure AD and Azure B2C, because traditionally you had to have different libraries, you had to install different DLLs, different NuGet packages, depending on whether you were targeting AD or B2C. So this gives you better access to the Azure Stack for Identity Platform. It doesn't replace ASP.NET Core Identity. So that still works exactly the same. That gives you the ability to, if you want to run it where ASP.NET Core looks after your users and creates users in your local database, that can still work. You're still going to have ability to wire in third-party providers like OAuth or Identity Server. But one thing to point out is Identity Server is moving to a paid model after the latest version, Identity Server 4. gRPC. So gRPC is a new way of sending data it's a remote procedure call framework for sending data between servers. So where XML sent quite big files with lots of markup and only a little bit of data, JSON improves it with slightly less markup, and a different format where you still have name value. gRPC is a highly optimized data transform, and we saw the post from James Newton King earlier. So what you do with gRPC? Well, it's got a slightly different syntax. You create these things called protocol buffers, and it uses a syntax that looks like this. Here's one for creating a person object. You can see it's got string and int32. They're very similar to .NET, but not the same as .NET. But you create these objects. You can take those objects and put them into a service definition. Once again, it is gRPC syntax. It's certainly readable to a .NET person, but you'll have to spend a little bit of time getting used to it to write it. But the key thing that happens here is you write this gRPC service, and then .NET will compile the server-side stuff to produce that service and to produce gRPC endpoints that can then provide that service. You then take that same protocol file and put it on the other side in that client, and it will generate a compatible service. So that could be in something completely different, like Ruby or PHP. So any other library, any other language that supports gRPC, in my eyes, it's faster and more strict than JSON. The problem with JSON is you're just basically making this big text file that just happens to build a JSON object when it's read by a JSON interpreter. gRPC is much stricter around strong typing and having a defined standard. So key points for gRPC. It's got a bit crazy. It's for remote procedure calls. So for communicating between two servers, and it uses HTTP2 to do that communication. It's faster and more strict than JSON. Another key thing here is it allows streaming connections. So you can open up a connection, send data through, keep that connection open, and send data as you've got it. And the other side will sit there listening, waiting for it. So great for those asynchronous streams of data. It's for server to server only. So it's possible to send gRPC requests to browsers, but you have to intercept a special proxy that'll do that communication for you, because the bits of the HTTP2 protocol that make gRPC work aren't supported by web browsers. So that has to bounce through a kind of translation layer via a proxy to make that work. To find out more about gRPC, we have an awesome talk by Liam available on YouTube. So just Google SSW up and running with gRPC. Next section, and we're getting towards the end now, changes for .NET Core. So with EF Core 5, one of the biggest big ticket features is support for many-to-many mapping. Now, this has been a big thing on the support list because Entity Framework 6, and not Core, but 6, did support many-to-many mapping. So what is this? Well, say I've got two objects. At the top, I've got this thing called people with Brendan and Jason in there. That's the gray one. And then I've got this list of skills. If you want to make that a many-to-many relationship, so for example, both Jason and Brendan in this example have the EF Core skill by the look of it, then I have to put a table in the middle to actually model those two sets of foreign keys. So in EF Core 3.1, you had to create an object in the middle, a class that modeled the object at that middle table. But now with the latest version of Entity Framework Core, it will generate that for you. You can have a person class, you can have a skill class, and you mark that as many-to-many in markup, and Entity Framework will automatically generate that middle table for you. You no longer have to do that by hand. Some other core features in Entity Framework Core, a similar but related one is table by type mapping. If I have a type hierarchy, so I have, for example, I have classes that extend from other classes. The way you do that previously is you'd have to create one class that contains the data of all the different types. So you end up with records that had lots of blank fields in them. So now you can actually split it up so that your subclasses go in their individual tables, yet no empty values in the database. But it does mean then querying those might take longer because you've got to look at multiple tables to fulfill the incomplete object. Some other features, Entity Framework has support for table-valued functions. You can create the function, you map it up in your configuration, and then you can use that table-valued function in your link statements. And you've got DB Context Factory. So previously, it was very easy to get Entity Framework configuration to give you a DB context. But if you had some kind of long-running operation where you need to use multiple DB contexts, you were pretty stuck. So this lets you inject a factory object that you can then manage the life cycle of multiple DB contexts yourself. And that comes in DB context and pooled DB context options. Some more features. EF Core 5 is going to get save points. So this is during transactions, you can get to a partial point in a transaction and mark a save point and roll back to that save point. You get a transaction ID, which helps you track correlation data on your transactions. A filtered include. If you have a navigation property between two things, say, for example, I've got a blog post and that blog post has many comments. If you were to ask Entity Framework to get me the blog post and include the comments, it would always give you all the comments. So what you can do now is say, give me the blog post and give me all the comments that haven't been deleted. So you can actually add an extra clause into that include statement and filter the data when following that navigation property. And finally, for EF Core, we've got an extension method on the query object called toQueryString. And what this does is it will just read your link statement and give you back the exact query string it would generate against the database. So previously, you had to do a bit of work to do this. You had to either dig into the Entity Framework configuration and set up some logging, or you could use the SQL profiler to look at the raw SQL. Now it's much easier to just grab that string and log it, or just take a look at what it's doing with your link statements. So that was a big section. Obviously, that's not everything that's new. That's all my favorite things about what's new. So the final step is what's coming. Well, we've hinted at this for a while, and it's the .NET 5 to 6 wave. It's the bit of this puzzle that finally reunifies the entire of .NET into one .NET for everything, and that's the .NET Multi-Platform App UI, or .NET MAUI. So here we're going to get a cross-platform native UI. And it's actually an evolution of Xamarin Forms. So starting with Xamarin Forms, they're building on it, they're making it run on top of .NET 6. And this is going to be the thing that lets us work with Xamarin on top of .NET Core. Now, the thing to remember here is when you work with Xamarin in some setups, what you do is you compile your application for native. So we're not talking about running .NET on the phone, because we're compiling still the application for native to run as a native package. But it means the whole tooling you use to build a Xamarin project will be .NET Core, which means those .NET Core project types and all the new features we've got there rather than what Mono's doing. So that for me is a very exciting future. Obviously, it would have been great to see this land for .NET 5, but I think we're right to take it carefully, get the .NET 5 move across, and I'm looking forward to this coming in .NET 6. The other thing to point out is .NET MAUI is in very early days. We've got some code on there. You can watch it happening, but you can see it's the code is kind of fitting up in this repository before your very eyes. So it's early days, but very exciting stuff. So the final bit is the .NET release schedule. So Microsoft have proven with their .NET Core lifetime that they're now much better at releasing versions on a predefined schedule. It's been brilliant to see. You know when it's coming. You can read the release candidates coming in when you're expecting them, and it's been great. So we can expect more of the same with .NET Core LTS being last year, .NET 5 coming out very, very soon, and then .NET 6 will be the next LTS. I find that a little bit interesting that the LTS version, the long-term support, is going to be the one that gets the whole new Xamarin support, but maybe it'll be .NET 6 is the LTS version and the Xamarin support runs on top. We'll have to see how the timing works out. It'll be whatever's best for the time. And what does LTS mean? LTS stands for long-term support. So that means every LTS version will be supported for 3 years from its release date. So once again, looking back at the .NET Framework, because the support is tied to Windows, has a much longer support lifecycle. But .NET Core is going to iterate much more quickly. So I'm still glad I'm on .NET Core, because the key thing to remember as well is there's quite a lot of back compatibility caused currently by the .NET Standard stuff. And what will happen in the future with .NET Standard is they'll stop having .NET Standard versions. They'll just start having the next version number will be 5 to match version 5 or 6 to match version 6. But they're not planning yet to drop anything from .NET Standards in there. So .NET 5 still supports .NET Standard 1, for example, and probably will for quite some time. Generally, the standards add features rather than take them away. Okay, thank you for watching. So far, we've talked about a lot. You've certainly earned 500 SSW points. I've earned 500 SSW points. And so scan this QR code and get your points, because points mean prizes. So to recap, we started with how did we get here, a history about .NET and .NET Core. We then looked at 2 project types, a .NET Core project and a .NET 4 project, and looked at the amount of work required to move them to .NET Core. Now, obviously, I've only got time to show some simple examples, but the big takeaway is .NET Core is extremely low risk. So .NET Core is extremely low risk. .NET 4 full framework is a bit more involved, but if you use some tooling or if you have a migration plan, it's achievable. And we looked at all the things that are new, and there's lots of it. And what's coming is the awesome fully unified .NET framework. So in summary, for .NET Core users, .NET 5 is a low-risk update. For everyone else, now is the time to migrate, because the .NET standard still applies. We don't know if it's going to still apply forever, but right now, the .NET standard still applies. The latest .NET Core libraries, such as Microsoft Dependency Injection, that's coming out for .NET Core, will run on your own framework. So start moving your code into .NET 4 compatibility on the old platform and then migrate. I think .NET Core is awesome. I think .NET 5 is better, and .NET 6, .NET 5 to 6 wave is where we'll get that final full unification. If you like this talk and want even more .NET 5, next week on Friday, I will be presenting with Jason Taylor a full day on .NET 5 at the .NET Superpowers Tour. So in that, we'll dig into the code a lot much more and have some real world examples of much more nitty-gritty details. If you have some feedback, scan this QR code and please do send us feedback. It really helps us tailor our talks and know what we got right, know what we can improve. I'll leave that there for a few more seconds, give you a chance to take a picture. And thank you.
Well, that was some talk, Brendan. Thank you for putting so much effort into that. I haven't seen a talk where it just kept on going, and felt like there was a number of recaps, and then you've got the .NET Core Superpowers as well. So there's heaps and heaps of this. A fun fact, Brendan. Mostly on these user group talks, we have a drop off near the end, but every 15 minutes of your talk, you were getting another 20% in your audience. So it kept growing as it got harder.
Yes. Yeah, that's unusual.
Yeah, so I'm going to ask you a few questions because I'm fascinated by a few things that got brought up there.
If you can fill in for just 30 seconds, I really need a glass of water. So just hold the line and I'll come back.
All right, so it sounds like Brendan is exhausted himself. I think if you have some feedback, give him the feedback by not just answering the questions in the form. The forms the link is in the chat as well. It's always good to have the comments and be harsh because he's going to deliver this talk a number of times, and you only get better with better feedback. One of the things that I plan on asking him is about customer expectations from .NET 4.8 to .NET 5, because you can imagine that customer confusion. I want to ask him some questions on how he'll talk to clients about the migration story. He did mention LTS, a long-term support, a few times.
Okay,
so
I'm
I'll ask
back.
Brendan. Okay, awesome. Thanks, Brendan. So I'll start with a few things. The first one would be how you communicate to a client, and I have a few parts to this question, but the obvious problem that I see is a customer that is in .NET Core world, the migration is going to be a lot easier, and a customer that is in .NET Classic 4.8, they only need to go to .NET 5, so it sounds super easy. That's going to be not much trouble.
Yeah, it does. The way it sounds is 4.8 is really close to 5, so it sounds like a tiny step. And .NET Core 3 to .NET 5 sounds like a massive step, but it's exactly the opposite. In fact, the .NET Core to 5 is a tiny step, and the 4 to 5 is really, really big. And that doesn't get communicated in the numbers. So cool. that is definitely an effort to communicate that across.
So let me just put you in a real customer scenario where you go in and talk to the customer, and they say, let's take the sample that you and Jason Taylor might use, which is the Northwind .NET Core 1 generated by his template. It's up on GitHub. Let's just say the client had something like that. To the customer, all right, we need to move that to .NET 5. Just say you're talking to the developers, the lead devs. What are the steps they need to take to get that one, which is in .NET Core, to .NET 5?
It's just upgrade your packages and test. It's as simple as that.
Simple? Yeah. Okay. So let's assume that was a very old project and you hadn't looked at it for years and years, and it was still in .NET 4.8. How would you explain to them what needs to happen to get that to .NET 5?
That requires a whole conversation because there is significant effort in this migration. It's not just an upgrade. So you have to evaluate the business value of this product. You have to talk to them about what is the life cycle of this product. Is this something you're going to evolve in the future? Is it doing 80% of its job and you want to add 20%? In that case, it may be fine to stay as it is. You can always, as I say, take what's existing and modernize it as is. Like, it's much better to stay consistent with it itself so someone can learn an application and it works, rather than start taking on this hybrid approach of whatever the latest technology was that week, let's throw that into the application. You end up with a hybrid monster. I think maintaining consistency within that application and achieving the goals of what that application is for is way more important than any consideration of what's it running on. Is it running on the latest? Is it .NET or is it a Node? Is it a Node server? Does it meet what I need it to do, and will it continue to meet what I need to do in the future? And are there any risks associated with how it currently is? Those are the key questions to ask anyone before we talk about what work we're going to do.
Okay, so let me throw you another question. Assume the customer is on .NET Core 3.1. I'd like to know, are there any scenarios where you might say to them, hold on. I don't think you should move to .NET 5 right now for this reason. And kind of some of the things I'm thinking about is they might have Entity Framework. They might have a lot of code with Entity Framework, and that runs on 3.1, but will that run on .NET 5?
Yeah, 3.1 towards .NET 5 is pretty easy. So Entity Framework Core, you took Entity Framework Core 3.1 to Entity Framework 5 is again a minor version bump. Yeah, the big change is Entity Framework 6, the old one, to Entity Framework 5. That's a migration. So the small version bump, Entity Framework Core 3 to Entity Framework Core 5, is small. So I wouldn't do it a week before production. I mean, things like change advisory boards get involved when you're talking about big organizations moving things to production. Not everyone has the luxury of being Netflix with their huge amounts of testing, and yes, we can just knock services over as and when we feel like it. And so we're not afraid of deploying at any time. Lots of people are afraid of deploying, and so you've got to work with these advisory boards and come up with a plan that works. So doing their own testing makes customers feel safe. Allow them to do their own testing, so you don't throw a spanner in the works and break something they spent 2 weeks testing just because a new version comes out.
All right, so let me ask you, what large enterprises do you expect many conversations about LTS, long-term support, and what specifics do you anticipate?
I'm not sure about this one because long-term support is important, but as a developer, support is never really a big issue for me. I don't generally raise support requests with Microsoft. I generally, and certainly since .NET Core is open source, as a developer, I'll go and look at the source files and work out why a problem. Why does that not appear to be right? I'll F12 and decompile the library and take a look. But LTS support is important for a feeling of safety. Just knowing that it is being supported, and there's a certain extra level of attention that Microsoft pays to their official libraries that you don't get when you get just other random libraries off NuGet. And that's one of the reasons why Swashbuckle is coming to the fore over, say, NSWAG. It's because on analysis of the code, Swashbuckle fits Microsoft's patterns and practices much more than NSWAG. Even though NSWAG has more features, Microsoft just aren't as comfortable with the code base after having evaluated it. And so those things all add up to it. But certainly for me, LTS is really about how long to run it through. But certainly if you're planning a piece of work and you're going to be finished and you're not going to make any changes after a certain point, then LTS becomes important, because that LTS, at being 3 years, if I make an application and I expect it to last 5 years, I need to consider how I need to come back in 2 years' time and reevaluate it, because it's going to fall out of support.
All right, cool. I might ask a question about security. I with .NET 5, Identity Server is no longer free.
That's
And
right.
I'm
Yeah.
just wondering, do you believe that the templates that Microsoft give us, that I believe will have Microsoft Identity.web, will be enough for you?
It really depends on your use case. Yes, I'm a big fan of Entity Server and its ability to give you this whole complicated, this whole stack, this whole complete identity stack for free. But I totally appreciate that, Dominic and the team there, they need to get paid for their work. They're doing a huge amount of work there, and they can't dedicate full time that this project needs without finding a way to pay for it. Now, they last year they tried to release a kind of add-on to Identity Server, which was more around sort of the next, after you've established identity, what is the extra set of claims you have around your roles and privileges. But I don't think it took off enough for them to be able to support Identity Server. So I think they had to take it off free. What that does mean is that we don't get the great experience of, I want to try this out. It comes with, it's an option I switch, I throw when I'm creating a project, and it comes and creates me a template project with Identity Server baked in. That's a tough thing to lose. But the reality is that people need to make a living, so I'm not gonna stand against that decision. So but it's a tough one now, because there's no exact answer that I have now. Is what is the thing I would do if you ask me in 2 weeks' time, what are we going to do? I'm not sure, but Azure is a great. I was always a bit skeptical about Azure logins until I tried it and sort of added it to an application and found took me 0 time and worked brilliantly.
Oh, awesome. Okay, so developers are avoiding monoliths now, and they're trying to do microservices. How much pain is removed with Project Tie?
It's a fair bit of pain, but I think the key thing with a microservice isn't the tooling you use. It's making sure you're making a microservice architecture and not a distributed monolith. So what I mean by distributed monolith is every application has dependencies. So if I need to have this operation happen, I need to go and connect this database over here and that thing over here. And I've seen plenty of microservice attempts where, in order to complete an operation through the system, every microservice had to query 2 other microservices to get the data to do its step. And so they end up with this huge amount of inter-service traffic going on, which has basically just made a monolith that's more, has this sort of microservice communication going on between it. You need to build microservices that stand alone for as much as possible and can survive the dependencies going offline. Either they queue up the work to be done, or they can work with cache data to continue working, so that you get that robustness. Because if you make a distributed monolith, you've made a monolith that's actually even harder to debug than the monolith you previously had.
Right. Okay.
But Project Tie definitely is a nice tool to help you deal with that, certainly with .NET projects.
Okay.
But it's very early days. I'm looking forward to seeing that have more work done on it.
Now, I know that we talk a lot about Blazor here, and I know in Sydney we're running a number of Blazor projects, and in Melbourne too. A bit less up there in Brisbane where you are. But I was, and obviously William Leonberg's talk on Blazor, which is a few months back on SSW TV, was extremely popular. But what is your feeling of Blazor in the enterprise? Do you feel you'll be embracing Blazor WebAssembly?
Yes, definitely. I am very keen. Because certainly in the enterprise, where what matters is people can run their application. Like in the enterprise, where you've got line of business apps, where you're using this application to do your job, the fact that it takes you 5 seconds to download the first page doesn't matter at all, because you're going to be looking at that screen all day. So, and I think the stability of having the same robust business function application, the same .NET code, being able to run driving your client side as well as your server side, has massive benefits. Now, there's been a school of thought in the JavaScript world that Node has taken off because it's taken the same idea. Well, let's run the same JavaScript code on the client side in the server. That's the benefits of running Node. But for me, it's taking the least good option, taking the worst option, but just putting it everywhere because at least it's consistent. So to me, having .NET on the server and in the client is brilliant, and it's what I've always wanted.
Okay, awesome. So I've got a stream of questions coming in, but I'm going to ask you two more. One from Matt Goldman, a Xamarin lover, is can you ask Brendan, Xamarin lets you target Windows, Mac, and Linux mobile devices and IoT devices, but you have to use different flavors of Xamarin, e.g. Xamarin.Mac to target those platforms, or the Xamarin.Forms cross-platform UI, and that only, Xamarin Forms only it only targets a subset of those platforms. Do you believe that Maui, the MAUI thing coming, will let us target all of them from a single code base?
I think that's the idea, but I think in reality there will always be some custom bits to target the native stuff. Xamarin's been good at having like a common library that you can build libraries with, but when you use the common stuff, it's not quite as good as the native stuff. So a lot of people just use the native stuff, and they have a mix of the core stuff that's common and then some native bits for each platform. I think that's quite common. I'm not a Xamarin expert, and I think that will still be the case. I think the main thing is that tooling will run .NET Core, so you're using .NET Core as a build tool and things like that. But really, what it means for Maui is so early, we're not quite sure what it will be yet. One thing I have noticed though is every single I've gone through a few posts about what Maui is, and they say it's running on all these things. Noticeably absent is Linux in that story. Supporting desktop Linux as the UI is actually quite tricky. It's something Mono does, but I think the Mono project in supporting Linux on the desktop hasn't got the same standards, the same support requirements as Microsoft would have. Like it's all very well making something that kind of works, but it's free and people have a go and they'll fix it as they work, to something that we say this definitely works, we're going to support it. It has to be more robust. Not to sort of denigrate Mono in any way. I think it's a fantastic achievement, but to just, there's a reason Microsoft didn't just take Mono or just take Xamarin. There's some work to do to build on it to solidify it enough to be something that you want to support, commercially.
Right. Okay. All right.
But that's one. An opinion. That's an
last
opinion.
one. So, can you ask Brendan how excited is he and how excited we should be about .NET 6 when we haven't moved our project to .NET 5 yet? I think the question is how excited are you about .NET 6, and how much energy should other people spend trying to know what's in .NET 6 when they haven't got to .NET 5?
It's an interesting question. I'm not quite sure I get the point of the question. So how excited am I about .NET 5? Very.
No, .NET 6.
.NET 6.
Yes. And how excited should other people do?
My personal thing is I'm interested in Xamarin, and I think Xamarin's a great story, but I don't really get to do Xamarin on a day-to-day basis. So for me, .NET Core was the thing. .NET Core and getting to run my microservices on Linux, that's what I care about, and that's getting better. So although it's the big unification, I understand that's a impressive feat. It's not something that affects me personally, because I'm much more, where I'm working at the moment is the microservices, Docker containers, Azure functions. Those are the things that I'm working on. If I have a different project, if I land a Xamarin project next week and suddenly spend some time in Xamarin, I might become a Xamarin guy. So a lot of a career is driven by what particular projects you get in what order.
Yes, that's right. Well, thank you, Brendan, so much for putting this talk together. It was a great effort. I think everyone really enjoyed it, and obviously join the .NET Core Superpowers if you want way more of this.
Even more, yeah, more of the same.
Yes. Okay, so thank you, everyone. This is Adam Kogan in the SSW studios in Sydney, signing off for SSW TV.
Thank you.